Okay, so we are talking about 𝜖-NFA conversion from 𝜖-NFA to NFA, then the DFA. So now we will discuss how directly we can construct a DFA from a 𝜖-NFA. So this is a little variant of the subset construction. So just to recap, so we have given a NFA, 𝜖-NFA, E delta q0 f, and from here we can have a NFA which is with the same set q delta prime, q0 is same f prime. Okay, so here delta is the function from q cross, we are taking the epsilon move to power of q. Okay, so now this is the set is same q, this is same, set of alphabet is same. Now here is a change, here is a change, here this is also same. So delta prime we are defining, this is the transition rule for this NFA. We are defining as this delta hat of delta prime. So delta prime is a function from q cross sigma to power set of q. So it is not allowing the epsilon move here for this. So we have to take care of epsilon move before a or after a for a given symbol. So that will be taken care by this. So delta prime of a state q and a alphabet a will be delta hat, this delta hat of q comma a. This is the way we define the transition rule for the NFA. So this means this, when you talk about hat, there is a difference between, in this delta there is a difference between hat and this. So this will give us a set of states, but it is not involve the epsilon move. But here hat means we consider a as before a there is epsilon, after a there is epsilon, because epsilon is just empty string. So we have to consider that move also. So that will be taken care by the extended transition function which is hat of this. So this is the way we define this, and then from here, so this is our NFA, from the 𝜖-NFA we have constructed the NFA, and from the NFA we know we can construct a DFA which is QD, which is basically the subsets of this, but now we do not need to consider all the subset, because some of the subsets are not reachable from the starting state. So those we will not consider, those are called date state. Okay. But in the worst case, if there are n state, it may happen that 2 to the power n is the size of this, but most likely in the many cases, I mean mostly there are only same number of states will be here. I mean we do not need to consider all the 2 to the power n states. Okay. But anyway, theoretically it is the power of q, but again we do not need to consider all the states, all the subsets, because few of the subsets are not reachable from the starting state. So this q d sigma is same delta d transition rule, and this q 0 this subset, and f is f d. So this is the construction called, we know this subset sum construction. Now we can prove that if a language is accepted by the, so this is D. So language accepted by this 𝜖-NFA is same as the language accepted by the NFA, which is same as language accepted by this DFA. So they are basically equivalent. So they are equivalent. So any language, I mean a language is called regular language if there is a finite automata which accept that, accept all the strings of that language. So if we have a given a language, we need to test whether this is a regular or not. We can because this NFA is easy to construct, epsilon NFA. So, we can just try to construct a epsilon NFA for that language, and if we can show that that language is same as the language of that epsilon NFA, then we are done, because we know that there is a corresponding NFA and there is a corresponding DFA which accepting that. So, this is the way we can do that. Okay. So, this is the, so now we will see how the directly we can come from this epsilon NFA to DFA instead of via this NFA. That is also a subset construction, a variant of subset construction. So, that we will see now. Okay. So, for that let us take the example. So, okay. So, let us take the example first, how we so suppose we have a given epsilon NFA. So, this example we have seen q 0, this is the starting state, and we have q 1 which is epsilon and this plus and minus, and from q 1 we can see 1 to 9, that is digit, it will be remain in this. Now, if you see a dot, we will go to q 2, and from q 1 there is another move to q 4. If we see 0, 1 to 9 digit, and here is a q 3 which is again moved by the digit from q 2, and if we see a dot from here, we will go to q 4 to q 3, and then at q 3 we will have a self loop with this input on the tape as digit, and then we reach to the final state q 5. So, this is our this is again by epsilon move. Okay. So, this example we take, we have seen this example before also. Now, from here this is epsilon NFA. We in the last class we have constructed the NFA and the DFA, corresponding DFA. So, the NFA we constructed is like this. This is just to show you the difference if we go to directly. So, the NFA was like this. So, for the NFA we just need to plug the epsilon move, nothing else. So, states are all same. So, this is q 0, q 1, q 2, and this is q 3, q 5 is here, and we have a q 4 over here. So, now this is the starting state, and from here we can go to plus or minus, we can go to q 1, or 0 to n also we can go to q 1. With dot we can go to this example we have seen in the last class. So, I am just copying. So, this is from here we can go from 0 to 9, any digit we go here. Now, with any digit we can go 0 to 9, or with any digit we can go from here to here, and with dot we will go to. So, we are just plugging the absorbing the epsilon move with the normal string. So, this is the way, and then we move to the from q 2 we go to the q 3 with 0 to 9, or directly we can go to the final state q 5 with the digit 0 to 9, and from q 4 with dot we can go here, or we can go there. And here is a self loop 0 to 9, and here also 0 to 9, any digit between 0 to 9. Okay. So, this is the corresponding NFA. If this is epsilon NFA, this is the corresponding NFA. Now, we have DFA also. In the last class we have seen the DFA. So, given a epsilon NFA, we have constructed this NFA. From this NFA, we will construct a DFA. This is same as that subset construction. Okay, so this also Q0. So, we consider, so from here to here. So, we have to consider all the possible subset of this, and we consider those subset which are reachable. So, we had that delta this transition rule table. So, I will just draw the diagram here. So, transition rule table is there in the previous lecture. So, Q0, Q1, these are the possible state we can go from the starting state, and here Q1, Q4, and here Q1, Q3, Q4, Q3, Q5, and here we have Q2, Q3, Q5, Q2, Q3, Q5. So, these are the possible state we can go from this. Now, with this is the starting state. Now, we have to write the transition rule. Now, with so from here to here we can go with plus, minus, dot, any one of this, no sorry, dot not, plus and minus. With dot we are going to Q3, and from here to here we go from here to here. If we see any digit 0 to 9, and here if we see 0 to 9 we will go this, and if we see a dot we will come here, and from here we can, if we see 0 to 9 we will go there, and here also 0 to 9 we hop there, and with dot we come here, and with 0 to 9 we go here, and 0 to 9 we hop there. Okay, and these two are the final state, because final state contain all the final state of this. So, Q5 is the final state. So, whatever in the subset Q5 is there, those will be the final state. So, this is the corresponding DFA from this NFA. So, we first constructed the NFA from the epsilon NFA, then we construct the DFA by the subset sum construction. So, this transition rule we have written in the last class. So, now we will talk about directly from the epsilon NFA how we can go to DFA. So, that is a variant of the subset sum again. So, that part we will do now. So, given epsilon NFA, how we can reach to the DFA directly. Equivalence. So, this is called equivalence of epsilon NFA and DFA. Epsilon NFA and DFA. Okay, so it is a theorem we can consider. Given a language is accepted by the same epsilon NFA if and only if the language is accepted by a DFA. So, DFA can consider as a epsilon NFA, because epsilon NFA is not necessarily that we will have a move for epsilon, that is optional. So, DFA can be considered as a epsilon NFA. Now, given a epsilon NFA, how we can construct a DFA directly, that we will look at. So, given a epsilon NFA, given epsilon NFA, say E q sigma delta q0 f, where delta is the function from q cross sigma union epsilon move to 2 to the power q. So, given this we have to construct a DFA. So, for DFA we write this as QD, sigma will be same because our tape is input tape is same. We put everything in the tape and then we keep on reading the tape one by one. So, this is same, rule will be changing because this QD is changing and obviously starting state will be changing and the final acceptance state will be changing. So, we have to define all this. So, this is same, there is no change in the input alphabet, this is a finite set. Now, QD, what is QD? So, normally in the DFA from the NFA what we take? We take the all the possible subsets, but here we are taking their closures also. Okay. So, we will take all the epsilon closure of the subsets, that is our state. So, that how we define that. So, let us just erase this. Okay, I will write it again. So, we have this NFA okay. Now, from this we are constructing the DFA. Okay. So, first of all what is QD? QD is the subset of Q or you can say QE if you like. So, subset of Q such that S is epsilon closure of S. So, we just consider we take a subset, say P 1, P 2, P k, we take a subset. Now, we consider epsilon closure of this, epsilon closure means by the epsilon move we can go to this. So, this is our capital P 1 say. So, similarly, epsilon closure of this is our capital P 2 say, epsilon closure of this is our capital P n. So, we take those union of this as our QD. So, QD is now the epsilon closure of the subsets. Earlier from NFA to DFA it was only the subsets, but here we are taking the epsilon closure of those states. Okay. So, we have a subset is consist of a states. So, we consider epsilon closure of those states. So, that forms the QD. Okay. Now, this is the QD. This is the QD. Now, we consider the starting state. Starting state is nothing but epsilon closure of Q 0. This is our Q 0 in the epsilon NFA. In the epsilon NFA, this is our Q 0. From this Q 0, the epsilon closure means by the arc with only epsilon level. That means epsilon move. If we can reach to, so this set, these are all, this is the set epsilon closure of Q 0. So, from Q 0, what are the state we can move? We can go with the epsilon move only, with no input reading. So, that is our epsilon closure of Q 0, that will be our starting state. Okay. So, now what is the and also final state we can consider as FD. We will talk about this after defining this. FD is nothing but, so set of all states, I mean this contain the epsilon closure such that S union F is non-empty. That is the way we define. Na? So, we were considering the subsets, which is again consider the epsilon closure. So, those subsets we take, among those subset which is having a having one at least one final state of E, then that is the FD. So, those subsets we consider as a FD. Now, we define the rule, the delta. Okay. Now, we define the delta. So, in the delta we will consider the, we will plug the epsilon move. So, let us define delta d. So, delta d of s comma a is the input. So, this we have to define where s is belongs to q d, again s involves the epsilon closure and a is a alphabet, is defined by, suppose s is say some p 1, p 2, p k. After doing this epsilon closure everything, we take the this one. Then we compute, the p I a with this delta e, and this is say I is equal to 1 to k. Okay. And suppose this set is reaching to R 1, R 2, R m. So, we take p I. So, we take p I, from p I it is going to some set, again we take p 1, we take p 2 like this. So, this is A with A. So, this set is our this R set. Now, from this R set we have to now consider the epsilon closure of each of these, and that will be our delta of this. So, that will be our delta of this. So, how to write that? Yeah. So, this is okay. We compute this, then delta of delta d of s comma a is nothing but union of epsilon closure of this R I or R j, j is equal to 1 to n. Okay. So, we take these p i's, from this p I we consider the move on A, we go to some of the states. Now, from there we consider the epsilon closure, where from we can go by the epsilon move. So, we are capturing this epsilon move inside this. So, this is our delta of s comma a. Okay. So, this is the way we define that delta of s comma a. So, now let us take a example, and if we have defined. So, this is the way we define delta. Okay. Now, let us construct that example. So, basically we are taking care of epsilon move in the state itself. So, we take the same example like we did in the beginning, but here we will try to construct the DFA directly without helping of the middle NFA. So, this is the given epsilon NFA. We have q 0, let me just draw it again, q 1, q 2, q 4 or q 3, sorry q 3, and q 4 is somewhere here. So, we have a move plus, minus and epsilon. This is the starting state, and from here we have a move, and with dot we can go here, again with the integer we can go here, with the integer we can go here, and with dot we can go there, and then with the integer we can, and then we will go to the final state q 5. So, this is our epsilon. Okay. So, this is our epsilon. So, now from there we want to compute the equivalent DFA. So, for the DFA we consider all the states which are just we consider all the states which are including the epsilon closure of this, and we find the delta. So, if you do that, so first the starting state is nothing but epsilon closure of q 0, that is our q d. So, epsilon closure of q 0 is q 0 and q 1. So, q 0 and q 1, this is the starting state, and then we consider all the state including their epsilon closure. So, q 1, q 2, then q 1, q 4, and then q 1, q 3, q 5, and then q 1, q 2, q 3, q 5, q 2, q 3, q 5. So, these are the states of this DFA, and these are the epsilon closure also. So, plus dot 0 to 9 any input alphabet. So, with the plus we can just check this will go to q 1 again, and this will go to q 1, and this will go to q 2, because if we are at q 1 q 2, if we have a dot, we can take a epsilon move to q 1 from so from q 1 we can go to q 2 only, and this is q 1 q 4. Okay. So, similarly, this is empty, this empty is also a state, because empty is a epsilon closure of nothing. So, epsilon. So, that is this is the q 2, we can verify this, and this will be q 1 q 4. So, this way we will continue. So, this will be empty, empty, and this will be again empty, and this will be q 3 q 5, q 3 q 5. Because from q 2, if we have a digit from q 2, where we can go? From q 2 we can go to q 3, or from q 3 again by epsilon move we can go to q 5. So, q 3 q 5. So, similarly, this will be empty, empty, and this will be q 2 q 3 q 5, sorry, q 3 q 4 q 5, sorry, q 2 q 3 q 5, q 2 q 3 q 5, and this will be q 1 q 4, q 1 q 4. You can verify this, and similarly this will be empty, 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 and this is q 3 q 5, and last one you can verify this. So, if you draw this picture in a graph, it will be like this. So, let me draw the graph. Yeah, so this will be like this. So, we have this is the starting state q 1, q 2, q 0 q 1, and these are the other state q 1 q 4, and then q 1 sorry q 2 q 3 q 5, and then we have a q 2 over here, and then we have q 3 q 5. So, these are the possible state for the DFA, and this is coming from the epsilon closure. So, if we have a plus dot, we go to this state. If we have an integer 0 to 9, any integer between 0 to 9 will go to this state, and if we have a dot, we go to this state, and from here if we have a dot, we come here, and from here again 0 to 9, any digit we go there, and if we have 0 to 9 from here. So, this is we can easily verify with dot. Now, from here 0 to 9 any input, and from here 0 to 9, and here we have a self loop with 0 to 9. Okay. And now, who are the final state? Final state consists of, so here final state is q 5. So, wherever the Q 5 content, that will be the final state. So, these two are the final state. So, this is the corresponding DFA. This is a variant of the substrate construction, but directly we are capturing the epsilon effect by this way. Okay. So, this is the example where from 𝜖-NFA we can directly construct the DFA. So, details will be given in the lecture note. Thank you.